Hey guys, so today's Wednesday, April 1st. Look, this is now day 3 of factoring for us. So I thought for today what we do is first talk about if we're factoring, what is a factor? So briefly, a factor is what we can multiply together to get an expression or product. So for example, if I said 3 times 2 equals 6, 3 is a factor of 6 and 2 is a factor of 6. So 3 is a factor, 2 is also a factor, and then 6 is the product that's made when I multiply these two factors together. So in that same way, if I look at example 2, if you look at these two factors here, this is a quadratic expression in factored form. This is the exact same quadratic in standard form. And if I look at it carefully, x plus 3, this here is a factor of this quadratic in standard form, and equally, x plus 2 is another factor that makes up this quadratic here. So x plus 3 we call a factor, and x plus 2 is another factor of x squared plus 5x plus 6. So what we're doing right now in this whole week is, as we're factoring quadratics, we're finding factors of a quadratic in standard form. So with that, let's make a connection. So we talked about before having standard form and factored form. And so these are not connected through this process of factoring. So to practice, let's example A here. Let's go ahead and factor this quadratic, which is right now in standard form. So to start, we know that A here equals to 1, B is negative 6, and C is negative 16. So next, I'm going to find the discriminant just to make sure that I can factor it. So b squared minus 4ac. B in this case is negative 6, minus 4a is 1, and c is negative 16. So again, you guys have calculators. If you can, use that. Negative 6 squared is 36. And then negative 4 times 1 is negative 4, and then negative 4 times negative 16 is positive 64. And if I add these together, I get 100. Now, this is a perfect square, so because 100 is a perfect square, that tells me then that this quadratic is factorable. The discriminant's 100, that's a perfect square, so I can proceed to factor this question. So with that, let's go ahead and move forward. In this case, up here, it's a times c, so 1 times negative 16 is negative 16. Down here is your b number, so it's negative 6. And then if I think about negative 16 and list all of its factors, so 1 times 16, 2 times 8, 3 doesn't work, and then 4 times 4. Which of these three factor pairs can make 6? And it's going to be 2 and 8, so I'm going to insert those in, the x factor. And then to make this work, I'm going to have to make the 8 negative, because if I do that, it makes this puzzle work. For example, first, 2 times negative 8 is negative 16, so that matches this piece, so that's a check. At the same time, 2 minus 8 is negative 6, and this response matches the bottom part of the puzzle, so this works. Guys, notice how so far I have a lot of work, but as you get faster at this, you won't have to do all this work the way I'm doing it now. You'll be able to see it in your head, and you can go much quicker. Okay? So at this point, the whole purpose of the x factor, again, is to split the original b term into two new terms. So, writing the original question, x squared minus 6x minus 16, I can now split my original b term into two terms that I'm going to pluck from the x factor. So now I'm going to put 2x minus 8x. So 2x minus 8x. I'll leave the same first term, so x squared, and the same last term. To finish this off, I'm going to now factor by grouping. So I'm going to pair the first two terms and the second term, two terms. And I'm going to GCF this 3 times. So first, in this little pair, what do x squared and 2x have in common? They both have an x to share, so I'm going to divide an x out of both of them, which leaves me with x plus 2. And then again, at this point, you can automatically put this as x plus 2 because they have to be the same. So the question is, looking at just these two terms, what will I divide these two by to result in an x plus 2? If I look at them carefully, they both have a negative 8. So I divide both these by negative 8. So that's what I put here. And to verify it, negative 8 divided by negative 8 is going to be my x. And negative 16 divided by negative 8 is going to give me a plus 2, so that works. To finish this process, I'm going to have my common x plus 2. If I take it out of both of them, you'll see that you're left with x minus 8. This is the factored form of your original question up here on top. So to show you the full circle, if I come to this chart over here, this was our original question in standard form, where we found A, B, and C. And after I factored it, I got factored form. So that's what this is here. So the factored form would be x plus 2 as one factor and x minus 8 as the other factor. To make my point, these two are the exact same. They're equivalent, but one is in standard form, one is in factored form, but they're the exact same quadratic. And then to verify for you real quick, example B says multiply the factors back together. So using the the box method process, x plus 2, then x minus 8. So if I just go ahead and complete this circle, so take your answer, let's multiply it back together. Look at what I get. I get x squared plus 2x. Here I get negative 8x. I'm just multiplying, and then minus 16. Again, so x times x is x squared, x times 2 is 2x, negative 8 times x is negative 8x, negative 8 times 2 is negative 16. And if I then combine like terms, which would be these here, I would end up getting x squared minus 6x minus 16. Notice how what I just did is I found my original question again. So compare the original problem all the way down here. I've completed the full circle. Now, before I move on, this is a lot of work for one question. This is not what the goal for the lesson. I'm just trying to show you how things connect so that hopefully they make more sense than just doing some random process to get some random answer. Okay, with that, to summarize, when we factor a quadratic expression or equation that's in standard form, we're simply just rewriting the original problem into a new form, which we know from before, called factored form. As a quick review of those terms, we had this back in note 73, where we showed you guys all 3 forms of a quadratic, the vertex form, standard, and factored form. And you have this already in your notes from before, but in vertex form, remember this was the easiest one to graph because in this form I can find the a value and the h and the k value, which was our vertex. In standard form, we could find easily the a value, which you can even see right here. And we could also find the y-intercept, which we learned before was going to be the c value. And then factored form had a purpose too, because in this form, remember, this here is called a factor. That's what we're doing now. We're finding these factors. And this is another factor, a second factor. And recall that in this form, we can find the x-intercepts really easily. But other words for that are going to be solutions, or roots, or zeros. So where we're going to head next is going to be, when we start to solve quadratics, it's going to make more sense once we put it all together for you. So with that, guys, this next note is again lengthy. It might look scary. We have 6 whole steps to factor now, but it will go much faster once we just practice the process over and over again. What I'm showing you right now is very lengthy. You can make it much less once you're good with how the steps work. So with that, look at these 6 steps here. I'm going to apply with them for you on the examples, and hopefully after a few times running through it, you'll kind of get the flow, and then we'll go from there. Okay, so the note is done. The note's the steps. Let's go and apply those steps here. So I'm going to show example C. So first, is this in standard form? In other words, can I identify A, B, and C here? And I can. So A here is 2, B is 8, and C is negative 24. However, if you look at the steps, it says to first make sure you're in standard form, then factor out a GCF if possible. So in this case, if I look at this question, I can use this A, B, and C, but they're kind of big. So let me not do that here. And if you look at this carefully, what do 2x squared plus 8x and minus 24, what do they have in common? And they all have a 2 in common. So in this question, before I do anything, I can divide out a 2 out of all 3 terms, and I can end up with this new, smaller quadratic, x squared. And then what's 8 divided by 2? That'll be plus 4x. And then negative 24 divided by 2 is negative 12. So in this case, I can first take out the GCF, which is going to be a 2, and get it out of the way, so to speak, and I can now just focus on that quadratic. So now looking at just that, I can now identify A as 1, B is 4, and C is negative 12. With that, I can find the discriminant really quickly here, so I'm going to go a little faster now. So I'm going to say B squared minus 4AC, and that's going to be 16 plus 48, which is going to be 64. And because 64 is a perfect square, I know that this is going to be factorable, so I can proceed. So now I'm going to factor. Now I'm going to go faster, so notice I can do this quicker. So 8 times C is negative 12. My B number is 4. Then 12 is 1 times 12. It's 2 times 6. It's 3 times 4. Which of these 3 factor pairs can combine to make 4? If you look carefully, 2 and 6 can do that. So I'm going to choose those as my values there. I'll make the 2 negative because 6 times negative 2 is negative 12, and 6 minus 2 is 4, so this works. At this point, I can take my original problem, which is here in this form. So I'm going to take this part here, and I'm going to split the b term, which right now is 4x. I'm going to split that into these 2 new terms. So instead of saying 4x, I'm going to say minus 2x plus 6x. That's still just 4x. And then I'll finish with minus 12. Notice how the front, x squared, stays the same. This c term stays the same also. I'm just splitting the b term into 2 new terms that I found from the x factor. Okay, then I'll factor by grouping. So I'm going to group my terms, and I'll GCF 3 times. So here I have an x in common. So x squared divided by x is x. And negative 2x divided by x. So take out the x and left with just negative 2. Then here, I can take out a 6, so I divide a 6 out of both of those. If I do that, 6x divided by 6, here the x's cancel, so I'm left with x. And then negative 12 divided by 6 is negative 2. And notice how, again, I expect this, but these are the same, so I'm good to go. So now I'm going to get x minus 2, and then x plus 6, and this is called factored form. So I factored. Again, to repeat, this is an equivalent version of this problem. Now, one thing I do want to do is when I have a GCF, I do want to include it in my final answer. So this 2 that I didn't use anywhere in the problem, once I took it out, it should reappear here at the end. So don't forget, if you take a GCF out in the beginning, you have to bring it back at the end for the final answer. Okay, with that, pause the video, try example D, and when you hit play, you'll see the work done for you. Alright guys, so here's example D. So notice how I went a little faster. I took out a GCF of 3 to start because I can do that. And then I focused in on just this quadratic, found the discriminant, it was a perfect square, so I moved forward, did the x factor, grouped it, and I found my factored form. So x minus 1 and x minus 9 are factors of this quadratic. Notice how I did forget something here still, which is the GCF of 3 that I took out in the beginning, so this should come back in. Okay, so with that, go ahead and pause the video again, and please try E and F, just best you can, and then I'll show you the answers for those. Afterwards, I'm going to show you example G, and then you'll try the others on your own, and that'll be the lesson. So go ahead and pause, try E and F. Okay, so if you tried E and F, guys, here's the work. Notice how I've made the work a little bit shorter by minimizing some of the work from before. So example E. This had no GCF, so I found the discriminant. It was a perfect square, so I moved forward, and I got my two factors, 2x plus 1 and x plus 3. Example F, this had a GCF of 2, so I took it out first. Then I just focused on this quadratic using A as 1, B as 11, C as 24. Found the discriminant, it's a perfect square, did the x factor and grouped, and I got my final answer is 2, which is the GCF. Then my two factors of x plus 3 and x plus 8. Okay, with that, let me show you example G. It's a little bit different. Example G, if you look at the way it's built, what's different about this quadratic versus the ones from before? It's missing something. Notice how in this case it's missing the x term. So this basically, if you look at it again, it's x squared plus 0x minus 16. So there are some cases where you're going to be missing one of your terms, and that's okay. So from here, I can identify A, B, and C. So don't get freaked out if you don't see everything. Just give it a coefficient here of 0 when it's not there. So we'll go through our discriminants. So B squared. So B squared minus 4 AC will be 0 plus 64, which is 64. That's a perfect square, so I can factor. So in this case, A times C is 1 times negative 16 is negative 16. Your B number here is 0, so in this case 0 goes here, and that's okay too. So now make a list of your factors of 16, so it's 1 times 16, 2 times 8, 3 doesn't work, and then 4 times 4. And notice how in these three factor pairs, which could make 0, and it's 4 and 4. So I'm going to pick those two numbers, make one negative, because 4 times negative 4 is negative 16. At the same time, 4 minus 4 is 0, so this works. So I'm going to put x squared, then minus 4x plus 4x, and then minus 16. Notice how the purpose of this factor again is I'm taking the original B term, which is 0, and I'm going to write it in a different way. And isn't minus 4 plus 4 still just 0? So this is still 0x, but I've now written it using my x factor. Quickly here, I'm going to group these guys. GCF 3 times, so here's the first GCF of x. Second GCF of a plus 4. And then to finish, I take out the common x minus 4, and I put x plus 4. And this is the factor, those are the factors of this original quadratic. Guys, with that, go ahead and pause the video. At this point, please try H, I, and J by yourself. Come back, check your answers, and on Thursday, we're going to just have another day just to practice the same process of factoring quadratics. Alright guys, so here's example H fully worked out. Please look over the work, see if you can follow it, and then you can get examples I and J here in a second. Alright guys, if you tried I and J, here's I fully worked out. This has a GCF, take it in the beginning, go through the whole process of discriminant, x factor, and then group. So here's your answer for example I. Guys, for example J, this is a little bit different because notice how it's missing the C term. But if I first find the GCF, there is here a GCF of x. So if I divide that out first, in fact, I'm done here because by taking out the x, it's already in factored form. Guys, with that, again, please, this is not easy. It'll take maybe a week or two to really figure out this process. So really all that time, we're going to stay on the same topic. So tomorrow will be just another day to practice factoring different kinds of quadratics from different beginning points. All right, guys, take care.